professor at the School of Civil and Environmental Engineering at Virginia Tech. Professor, you are a good person for us to be talking to about this disaster. One of the other things that we heard from Transportation Secretary Pete Buttigieg on Tuesday is that he said he doesn't know of any bridge that could have stood direct impact from this massive vessel. Do you agree with that assessment?
Yes, very much. I agree with that. And by the way, thank you for having me on the air. The fact of the matter is that bridges of this type are not designed to resist impacts in the transverse direction that are anywhere near what this this ship brought into bearing. It's a very unusual load. It was a very large mass moving at quite a speed. It was 8 knots is about 9 miles an hour. And so if you actually look at the video, and I assume most of your viewers have looked at it, and you see this enormous mass bearing onto this very light bridge, you do get the sense that the bridge didn't have a chance. And so the bridge didn't have a chance primarily because there were no real protective structures around the pier.
Well, let me ask you that. Let me stop you there. What would have happened if there had been protective barriers or fenders around these piers? Would the outcome be very different here?
Well, I can only speculate, of course. The answer is it would have depended whether the design actually took into account this massive ship. We have to understand that the size of these ships has increased tremendously. And even this Dali ship is only is 2.5 times smaller than the largest container ships that we have today. So these have come about in the last 15 to 20 years. And so if the bridge protection system was designed 20, 25 years ago, it was for a very different kind of ship. So, one of the issues that we have is not just, did we build some protection initially, but is it relevant to today's loads? The same thing applies, for example, to the trucks on the bridge. We have much heavier trucks, many more trucks than when these bridges were designed. And that's the reason we need to give them not only good maintenance, but also rehabilitation and make them stronger.
Let me tell you about a recent data. This is as of 2023. The Federal Highway Administration said more than 300,000 bridges, Professor, were determined to have been in fair condition. Another 42,000 were in poor condition, including some large spans. Should we be concerned? 42,000 bridges in America are in poor condition and millions of Americans are driving on these bridges?
Well, yes, we should be concerned, but you have to understand that the DOTs have a very active program looking at what the bridges are. They inspect any major bridge every 2 years. If they find any serious deficiencies or things that might concern them, then they stepped up the inspections to every year and sometimes even every 6 months to monitor what's happening. So it's not like the state DOTs and the federal government are not doing their best. The issue is the lack of resources to do the rehabilitation that's needed. And so this is a problem.
By lack of resources, you mean money?
Money. And the Congress approved what to many people was a very large package for infrastructure repair and rehabilitation last year. That is a fraction. It's probably a 1/6 to a 10th of what is actually needed. And so, yes.
Go ahead. I interrupted you. Go ahead, Professor.
No, it's just a matter that the needs are not being met by the resources necessary. And so the DOTs and the Federal Highway Administration has to make choices and make compromises and they do their best that they can. I am not concerned really about driving over bridges. And the reason that I'm not really that concerned is that I understand that the people taking care of these bridges are very capable. And the accident that we had on Monday is a very rare occurrence. The other side of that is a very high consequence of occurrence, right? Because of the impact it has on the city of Baltimore and even global trade. And so this is a very unusual circumstance.
And
And
very,
so this is,
yeah, and Professor, finally, I got to ask you about the recovery of this black box, a key piece of evidence critical in establishing a timeline as to what exactly happened and how it all unfolded, isn't it?
yes, definitely. And you know, there are a couple of things that are important here. One is it should have recorded the voice and to make sure that all the procedures that are in place to assure that the ship is worthy of seagoing were done before the ship left, and then to trace what was the sequence of events that led to the failures and why. Primarily, I'm interested in what is called forensic engineering or failure analysis. I'm interested in why the backup systems did not seem to work. You know, in a ship of this size, there have to be 2 or 3 backup systems for critical functions like steering of the ship. You know, it just cannot be
Well, the
one
power
system.
outage there might have played a big role in that one, but we're going to have to leave it there. Professor Roberto Leon joining us from Blacksburg. Thank you very much.
Thank you.